This video will describe interpreting the output data of the Backbone Demo 1 model. To run the model and generate the results, please see previous video on how to install Backbone and run demo model. After running the full year, invest and schedule run, the model has first optimized the capacity investments on new units and new transfer lines. The calculation is based on representative sample weeks that are selected in investinit.gums. The invest run has generated the output file investresults.inc. When we open the file, first we have the number of new subunits that were invested into. Looking at the input data, we see that some subunits are only 1 megawatt in size, while others are up to 500 megawatts. The number of subunits is multiplied with the unit size and then added to the capacity listed next. Some investments are made on new storages and new transfer lines. After this, the invest parameters are turned off. When running the combined invest and schedule run, these new investments are added to the model and the full year schedule run is optimized with the new capacities. The least overall cost unit commitment problem is solved for each hour, resulting in dispatching the units in a cost-optimal way while honoring the demand and constraints. Let's open the results GDX in GUMS editor to look at the results. There are many tables here, some representing time series and some aggregated results. For example, RGen shows the energy generation for each unit at each time step. The table can be modified by clicking and dragging. Here we see, for example, that the wind unit has generated 543 megawatts at time step 1. Notice that if a certain unit does not generate at a certain time step, then that time step is not listed in the time series. Then at RGNU total gen, we see the aggregated results for the whole units, for the whole run. So for example, the wind unit has created this many megawatt hours over the whole run. The name of this result table translates to result in grids, nodes, units, total generation. Similar tables exist for transfer lines, states of storages, emissions, and costs. Many of these results are not in a very useful form, and for further result analysis, the results can be converted to Excel using a GDX XRW conversion tool. This bit is not, however, included in the Demo 1 package, and it is up for the user to process these results. This video concludes the short introduction to Backbone Energy Modeling Framework and Demo 1 model created for it. Notice that we have not gone through all the details, and to learn the usage of Backbone will require spending many hours studying. If you are interested in starting to use Backbone in your own research project and want further information, then please contact this address.